Hello there, this is Ms. Nakayama, and today's lesson is 8.1 Matrix Solutions to Linear Systems. So, hope you can recognize linear systems as we're building upon what we just did in Chapter 7. So, first off, our objectives, we are going to learn how to write the augmented matrix for a linear system. Then we're going to perform matrix row operations. We're going to use matrices and Gaussian elimination to solve systems and Gauss Jordan elimination to solve systems. So first off, let's refresh your memory on what a matrix is. Okay, matrices are used to display information and solve systems of linear equations. A matrix, plural, singular, matrix is singular of matrices, is a rectangular array of numbers, okay? A rectangular array of numbers is what we have right down here. It just means that you have rows and columns. And if you get confused, it's kind of important to know which one's which, but columns are what you see in front of a house. So columns are vertical and rows are horizontal, okay? But each number inside of this matrix is called an element. So those are the elements of the matrix. The other thing I don't know that you need to as much. We'll keep going. Okay, so first off, with augmented matrices, okay, we've got to be able to write a system of linear. So we're dealing, y'all, this is exactly what we just came from, Chapter 7. But we're going to be able to take a system of linear equations and write it as an augmented matrix. It's an augmented matrix when it has a vertical bar separating columns into two groups. And we have the coefficients that are going to show on the left side of the vertical line, and we're going to have the constants that are going to show on the right side. And if any variable is missing, then of course its coefficient is 0. So look at this first example. Write the augmented matrix for each system below. So here is my system of equations. Now we're going to go write an augmented matrix. So you've got to make sure that all of your variables are lined up. So all the variables have to be on the left side. This vertical line is basically representing the equal sign. That's what we have right here. So my top row is going to be 3, 1, 2, and then 31. So that's what I've got for the first row. 3, 1, 2, 31. Next row, 1, 1, 2, 19. And then 1, 3, 2, 25. That's all it is. All right, look at the next one. Okay, the first row, 1, 2, -5, and -19. But if you notice on the next one, okay, and again, it helps to line up those variables. So this is going to be 0, 1, 3, and then 9. And then the last one is going to be 0x, 0y, and 1z, and then a 4. So that is one thing you got to know how to do. Next, we're going to talk about something called row operations. Now, if you will just keep in mind that these row operations, y'all, are what you do when you work with elimination with a system of linear equations, then it all falls into place. So first off, if you look at this matrix down here, okay, any matrix that has ones on the main diagonal, this is the main diagonal here, and it has ones there, and it has zeros below the ones, all zeros below the ones, it's said to be in row echelon form. Okay, we use row operations on an augmented matrix to produce it. So this particular one is in row echelon form. Now, the row operations that you're going to be doing, just like we do with linear systems, okay, first off, you can switch any two rows. It's just like switching two equations in a linear system, okay? The elements of any row can be multiplied by a non-zero number. It's the same thing as multiplying both sides of an equation. So, well, I'm going to keep going. Sorry, I get too excited. The elements of any row can be multiplied by a non-zero number, and these may be added to corresponding elements of any other row. Again, same thing you do when you have equations. The difference, y'all, is we just don't write the x and y's and z's because we keep them in order, and we know that they are the coefficients. Okay, and two matrices are row equivalent if one can be obtained from the other by a sequence of row operations. So Here are the symbols, and you have to know these symbols because you have to write them, and you have to be able to understand what they mean when you're asked a question. So if you're going to interchange two rows, then you write it like that with an arrow pointing both ways between the rows that you're switching. Okay, if you're to multiply all the elements in a row by k, then you write k times big R, and the I is going to be whatever row you're multiplying by. Okay, if you add k times an element to a row, then we're going to write k R sub I plus R sub j. What is important about this one, y'all, is this second one is the row that is actually replaced. So you need to remember when you write it, and you'll see as I go through, that this is the row that's being replaced. So you're multiplying a different row by some number, and you're adding it to this row to replace that row. Okay? So look at this. These are examples of just straight up performing the operations. Use this matrix and perform the indicated row operation. So it says switch rows 1 and 2. So I'm just going to 1 and 2. So that means instead of having a 4 up top, I'm going to have 1, 6, negative 3, and 7. And then row 2 is going to be what was the first row, 4, 12, negative 20, and 8. And then we have negative 3, negative 2, 1, and negative 9. And that didn't switch. Okay? It is as simple as that. Okay? Next one. This one says take 1/4 of row 1. Okay? So that means, come up a little bit, the other rows stay the same. And a lot of times when I'm doing something, I actually write those rows first so I don't get confused. So I'm only changing row 1, 1/4 of 4. This is the same thing, y'all. There is no division with multiplication. So they write it as a fraction. Okay? So 1/4 times row 1 is the same thing as dividing everything by 4. So 4 divided by 4 is 1. 12 divided by 4 is 3. Negative 20 divided by 4 is negative 5. And 8 divided by 4 is 2. And that's all that is. Okay? Now the hardest one, but not really, is use this matrix and perform the indicated row operation. This says 3 times row 2 plus row 3. Okay? And remember, this means that row 3 is the one that's going to be replaced. So when I write this, if I'm replacing row 3, then row 1 stays the same, row 2 stays the same. Now, I've got to do, and this is mental math, or if you need your calculator, 3 times this number plus that number. Well, 3 plus negative 3 is 0. 3 times 6 is 18. 18 plus negative 2 is 16. 3 times negative 3 is negative 9. Negative 9 plus 1 is negative 8. And 3 times 7 is 21, and 21 plus negative 9 is 12. So that's what that looks like. So those are your different row operations, and now we got to figure out how we're going to put all that together with the first thing called Gaussian elimination. So we do these row operations, and there is a process that simplifies it, and that is when you have a matrix, okay, you always want to start by getting this guy up here, top left, upper left-hand corner. That's where you want to start and get your 1. And then think about columns. So when you go to the next matrix, you're going to see what you can do. Use the 1 at the top to get zeros in the below the 1. And then you go to the next column and you get a 1 in that spot. And then after that, you go to keep staying in that column, use that 1 to get zeros below it, and then go to the last column and get a 1. And this, as we referred to before, is that row echelon that we're trying to get the matrix in. And after you do that, what you're going to see is going to happen is we're going to use something called back substitution to find the rest of the solution to the system. So look at this example. Use the matrices to solve this system. Okay, so remember, that we want a 1 in the top left corner, upper left-hand corner. And remember that we can switch any two rows. So when I write my first matrix, I'm actually going to go switch these two rows when I even start it up. So my first matrix, that is not my first matrix. Excuse me. Come on. No, I hit the wrong thing. All right. So my first matrix is here. And so I'm going to switch those two rows. So I'm going to have 1, negative 1, 2, 9. And then I'm going to have 2, 1, 2, and 18. And then I'm going to have 1, 2, negative 1, and 6. Okay, so we got a 1 in the top left corner. Now I'm going to use that 1 to get zeros below it. Okay, so when I get those zeros, it doesn't matter which order you do it, but I'm trying to conserve on how much we have to write. So the first one I'm going to do is the second row. And when you use the 1, y'all, if you multiply the 1 by the opposite of what you have here and you add them together, you get the 0. Okay, so that is the easiest way to get a 0. So on this first one, I'm going to multiply row 1 by negative 2 and add it to row 2. So negative 2 times row 1 plus row 2. And that's going to give me, and actually before I write that, I'm going to write the first row again, y'all, because that row is not going to change. So this next row, negative 2 times 1 is negative 2, and negative 2 plus 2 is 0. Then I'm going to go negative 2 times negative 1 is positive 2. Positive 2 plus 1 is 3. Negative 2 times 2 is negative 4. Negative 4 plus 2 is negative 2. Negative 2 times 9 is negative 18, and negative 18 plus 18 is 0. Okay? Now, the next thing I'm supposed to do is get a 0 down here. So I'm going to use this one right here. And this time, I mean, you can think about it as subtracting, but you're multiplying this row by negative 1 and adding it to that. So negative row 1, I wrote it up here. Negative row 1 plus row 3. And remember, the second one you write is the one we're replacing. So negative 1 plus 1 is 0. Negative 1 times, so basically it's the opposite of this, y'all. So negative 1 plus 1, 1 plus 2 is 3. Negative 2 and negative 1 is negative 3. And negative 9 plus 6 is negative 3. Okay, so I have my first column done. 1 in the upper left, zeros below it. Now I want to get a 1 here. But I actually see that this right here, y'all, and this is something that just takes with practice, okay? You could divide everything by 3 and have a 1, but then you're going to have fractions, and I don't really want fractions. So I see that I could divide this row by 3. So I'm going to go do that. When I divide this row by 3, let's see, where am I? Okay, so my top two rows are not going to change. Come on. Okay, and then I'm going to divide 0 divided by 3, 3 divided by 3, negative 3 divided by 3, negative 3 divided by 3. And now I'm going to just switch rows 2 and 3, which is what that says. So again, top row is not going to change, but I'm going to switch the 2 and 3. So I'm going to have 0, 1, negative 1, negative 1, and 0, 3, negative 2, and 0. So now I have my 1 in that column, in that spot. And now I got to get a 3. I got to get rid of that 3. I got to make it a 0. So I use this 1 right here, and I'm going to multiply it by negative 3 because it's the opposite of what I'm trying to get to, a 0. And I always write it next to the row I'm replacing. So it's going to be negative 3 times row 2 plus, and that doesn't say plus. I got to fix that. That's supposed to say plus row 3. And what do we get? We're going to get, again, first row doesn't change. Second row doesn't change, but the third row. So 0, I'm multiplying this whole row in blue. I'm multiplying it by -3. So 0 times -3 is 0. 0 plus 0. That's why you kind of do it in that order, y'all. 1 times -3. 1 times -3 plus 3 is going to give me 0. All right. -3 times -1 is +3, and +3 and -2 give me 1. -3 times -1 is +3 again, and 3 plus 0 is 3. Okay, so this is what is referred to as Gaussian elimination in getting it into row echelon form. I have 1s down my main diagonals, and I have 0s everywhere else. Okay, and so from here, I can use back substitution. And what this says, remember, these are my x coefficients, my y coefficients, and my z coefficients. And these are my constants. So the same thing is true in this matrix. So that means the bottom row, 0x, 0y, 1z is equal to 3. And the one above it in blue says 1y minus z equals -1. And the one above it says x minus y plus 2z equals 9. So I have z equal to 3. So I get those equations from my reduced echelon form, row echelon form. And now I'm going to take z equal to 3 and I'm going to go plug it into that equation. And that's going to give me y minus 3 equals -1. So y equals 2. And then I'm going to go plug it into the orange equation, where it's going to say x minus y, which is 2, plus 2 times z, which is 3, equals 9, and that gives me x equal to 5. And so the answer is an ordered triple, just like we did in the last chapter. X, Y, Z is going to be 5, 2, and 3. Okay, so now the last thing that we have to talk about is Gauss Jordan elimination. And this, you can come back and read it. You can pause it and read it, okay? But really, when you do this, you're actually getting the matrix all the way into reduced row echelon form, and that means you don't have to do back substitution. So that means on this particular one, and you're going to see I'm going to go finish it, okay? So if I take this guy right here, who's in row echelon form, and I'm going to finish it. So this matrix is the same as this problem right here, okay? But I'm going to pick up, where we left off with that matrix, okay? So I had, we reduced it down to this point, okay? This was row echelon form. So if I'm going to continue to get to Gauss Jordan elimination, then that means I got to get these guys to zeros, okay? And so from here, you go column by column. 1, zeros, and then I went to the 1, and we only went to this 0, but then we would normally go here if we're going to do that. So the next thing I'm going to do is just have to add those two rows together, but I'm replacing row 1. So it's just going to be row 2 plus row 1. Okay? So row 2 plus row 1, 0 plus 1 is 1. 1 and -1 is 0. And -1 plus 2. Okay? I'm in this right here. -1 plus 2 is 1. And -1 plus 9 is 8. Okay? I'm not changing the others. Okay? Now I have to get zeros here. So I have this column 1, 0, 0. Then I have 0, 1, 0. And now I'm using this 1 at the bottom to get zeros here and here. So when I go to my last one, okay, and I have it, I'm going to change that second row. And I'm going to have, what am I going to do? I'm just going to add them just like we did before. So it's going to be, I'm replacing row 2. So it's going to be row 3 plus row 2. Okay? Bottom row stays the same. Okay, I don't want to do anything to it. And now you just have to add, and y'all the arrow pointing to where you're doing this really helps. I hope you'll write this on your paper because it helps you keep straight. And if you write the row that's not being changed, then you won't put things in the wrong place. So you're just adding these two rows, 0 plus 0, 0 plus 1, 1 and negative 1, and 3 and negative 1. Okay, and now I have to get a 0 here. So this time I'm still using this 1. You have to use this 1, y'all, or you'll lose that 0. So I use this 1, and this time I got to multiply this one by negative 1. So it's going to be negative row 3 plus row 1. And so negative 0 plus 1 is 1. 0 plus 0 is 0. Negative 1 plus 1 is 0. And now I have negative 3 plus 8. And that's 5. And this is what is referred to as, I didn't write it. This right here is referred to as RREF, reduced row echelon form. This is row echelon form. This is reduced row echelon form. But this tells you X is 5, Y is 2, and Z is 3, which is exactly what we did in the previous question. So you can either continue to get to all the zeros, or you can stop at that point and do the back substitution. Okay. The last thing I have to talk to you about is technology, because you will do some of these. You will have to do one of these by hand, but you will also need to know how to do it on a calculator. So we're going to use ClassCalc, okay? And I'm going to show you how to do this on ClassCalc. So we get our calculator out on your phone, okay? If you pull up ClassCalc, it normally comes up to graphing. So you click over here in the upper right-hand corner, and you go down to Matrix. And it looks like this. Gives you some hints if you need that, but you're just going to click on New Matrix. And if you can see, this is a 2 by 2, but we have to have it. We're going to put this whole thing in here. So this is 1, 2, 3, 4 columns, 3 rows. So you just need to look like that. So we said 3 rows and 4 columns. So it looks like that. Okay, so we want to put it, we aren't going to be able to see that vertical bar down here, but we're going to put all of our coefficients on the left and our constants on the right. So we have 2, negative 3, negative 4, and 41. And if you just hit the tab button, it just goes over negative 4 and negative 21, and then 1, negative 3. There is no Z, and 19. If you hit enter, it just displays A. Y'all, these problems are not hard, but it's worth your effort to go and look and check your numbers vertically with your system, negative 3, 5, negative 3, negative 4, 0, because if you mess one little number, you're going to mess up the whole thing. Okay? So the directions say use Gaussian elimination to obtain the matrix in row echelon form. So row echelon form is right here. REF, and then you have to hit A for that matrix. It's in decimals, but if you look at this, see how this says 1, negative 1.5. So I'm looking for one that says, and none of them say that. So I wanted to point this out to you because just like I did when I did it by hand, y'all, this has a coefficient of 1. So it looks like they have put this row up here, and so they just switched these 2 rows. So I'm going to go back here, and I'm going to go hit enter to get rid of that. And I'm going to hit a new matrix B, and I'm going to switch those 2 rows. So I'm going to say 1, negative 3, negative 4, 41. Nope, that's not right. 1, negative 3, 0, and 19. And then it's 5, 5, negative 4, negative 21, and then 2, negative 3, negative 4, 41. So I just switched rows. No, because that's supposed to be. And so look at this on ClassCalc, y'all. You can go back up there and you don't have to type the whole thing over again. I can just come here and say that was supposed to be a 2 because my top row was 2, negative 3, negative 4, and I had typed in a 4. Second row is right. First, all right. So I got that now. There's my B. Okay. Now if I do REF and it's B this time, I have 1, negative 3, 0, 19. 1, negative 3. So it's going to be one of these 2. It's not either one of these. And then I have 1, -6. They both have 1, -6, so I got to look and see which one of these does it have -1/5 or 29/5? Well, this number is less than 1, and this number is more than 1. So when you look at it, that is less than 1, and that is more than 1. So that means that my answer is B. Okay, so that's my answer. This, of course, is REF. Okay, that's how we got that. And then to actually get the solution set, you can either go and solve that with back substitution, or you can just go back here and say, okay, enter. Let's go RREF, and you can do A or B because you'll get the same answer either way. And that tells us that we have -2, -7, and -6. So the solution set is that. And that's all you have for, I'm going to write this down so you don't forget. RREF is what we did to get that. That is solving matrices with row operations and using ClassCalc, your technology. If you have a different calculator, I'm happy to help you use it. But please write down any questions you have and come see me or email me if you have any questions or anything you'd like to say. Thank you so much for watching, and y'all have a great day.